We're going to continue doing the rational graphs. We always like to start with our asymptotes and intercepts. And to follow up on our last video, I want to show you how we can use something called a sign chart to actually analyze the rest of the graph. First thing we always do is we want to factor it. So the first thing I want to do is I want to be sure that I understand all the factors here. So I can ask what x makes 0. Looks like what? 5 and 2 with a negative on the 5 and a positive on the 2. Double check. Negative 10, middle term, negative 3x, it checks. Okay? We're going to do our what makes 0, questions on top and bottom first. What makes 0 questions on top and bottom first. So I'm going to look at what makes 0 there and there. On top, on the numerator, if I ask what makes 0 on the numerator, I get an x-intercept of negative 1, and I'm going to put that dot. I get an x equal negative 1 intercept. Okay. Down at the bottom, I've got vertical asymptotes. These are going to be our VAs. They would be holes, but none of them are removed. So our vertical asymptotes are at x equal 5 and negative 2. Let's throw those in. 2, 3, 4, 5, right about here. Okay, and over here, we're going to do x equal negative 2. Try to get the basics in there. Get that graph in there. Okay, negative 2. So there's the asymptotes. X equal negative 2, x equal 5. Okay, those are the what makes 0 for numerator and denominator. That helps accelerate that process. Let's go ahead and plug and chug an f of 0 to get the y-intercept. So that y-intercept looks to be a negative 1/10. So just a crack below, just a little bit below. Cool, a little dot right there. Now, the last thing I want to do is plug and chug the big numbers, which is our in behavior. I like to just think of it as plugging and chugging gazillions. Okay, so one way to look at that is just look at the most powerful things. Okay, on top and on bottom. The numerator's degree on top is 1. The numerator degree on top is 2. So if you simplify that, that really simplifies to x over x squared, or 1 over x. So if you plug and chug a positive big number, should be 0. Should go towards 0. If I plug and chug a negative big number, it also should go to 0. So I now have a 0 asymptote that I'm going to put right over the x-axis. Y equals 0. As we did last time, because of continuity in the function rule, the graph has to either exist up here on the upper left or on the lower left. So it's one or the other. So it's got to exist in one place or the other. We've got to figure out which one. We could talk about what it means to plug and chug negative numbers in here like we did yesterday, and we could make sense of whether the graph is below or above. But I'd like to use a sign chart to give us a basic idea. A sign chart. I'm going to actually explain what a sign chart looks like. Some sign charts are across a number line, which we will do in the future. Some sign charts are basically just asking what is the signs in these 3 items, these 3 binomials in the original graph. So if I plug and chug values in this x, and this x of the 3 binomials that make up the rational, what will the signs be? You don't have to compute numbers. You just need to compute whether it's positive or negative, because the graph is either going to be in the positive or in the negative. So I'll pick a number left of negative 2. How about somewhere over here, like at negative 4? At negative 4, if I plug in the numerator up here at x plus 1, is it positive or negative?
Negative, sorry.
Negative, I believe, right? So negative 4 should be negative. Cool. Plug and chug a negative 4 here. Looks like negative. And down below, if I plug and chug a negative there, negative 4 and negative. So understanding just this fraction's answer is 3 negatives, the answer positive or negative?
Negative.
This answer is going to be negative. We now know the graph must be down here. Now, I may be hitting all the right points. I may be hitting very few of the correct points on the graph. That's why we're just throwing a general sketch. It's sometimes good to plug and chug points. So I could actually get a value here for negative 4 and get a better curvature. But right now I want a general sketch. So any kind of 1 over x rational graph look over here is fine. Let's go to the far right side. Let's go beyond 5. Let's head over here and check out like maybe x is 7. At x is 7, same idea, positive or negative in all these answers. So I'm going to come back and use this same graph. So what do we got? X plus 1, positive? Positive. If I plug and chug a 7 there, positive. And if I plug and chug a 7 at the x plus 2, positive, all positive. I now know where the graph's at. The graph must exist up here on the top, outside right part. So this is a fast way, instead of plugging and chugging points, or doing analysis by plugging and chugging big negative numbers and big positive numbers, you can actually get the gist of it, get a sketch of it pretty quickly. So just to make sure we're all clear, and because it came up in a question right now, I know that this red part of the graph, this graph right here, this graph may be slid over a little more, maybe a little left, but it doesn't cross the x-axis. There is no x-intercept here because up in the original one up there, x plus 1's numerator, there is no binomial that makes an intercept over here on the left of -2, basically. So what happens in the middle? The middle, well, we might have this kind of cubic looking thing happen. That's possible. I've seen that. Let me undo that real quick. Okay, the graph could, because the intercept's right on the axis there, it could make like this upside down parabola looking thing. So it could be this upside down parabola looking thing. It's hard to tell. One thing's for sure, I'll tell you, it cannot do this. It cannot do this. It cannot go up, hit that intercept at -1, bounce down, hit that y-intercept at -10, and suddenly go up.
Because there'd be another intercept.
Exactly, because there would be another intercept. So that's impossible. So now I'm pretty sure, in fact, I'm positive, from the -1/10 point, it's got to head down towards that asymptote. The limit, as I go into the 5 from the left, remember the little negative sign on top of the 5, as I go into the 5 line from the left, it's definitely heading to -infinity, mainly because there's no x-intercept here. It's impossible. It's continuous. It can't jump. It's got to head down. But over here, it still has the ability to go up or down. It has the ability to go maybe up or down. It could have crossed or it could have bounced off the axis. So what's a value between -1, the intercept, and -2?
-1.5.
All right, so I'm going to check out -1.5, and I'm going to do the sign test again. So I'm going to take a look at the signs again and just build this little sign chart, table, something. I don't know what to call it. So I don't think it's actually called the sign chart, but we're just going with it right now. So if x is -5, let's plug and chug the numerator. Positive or negative?
Negative.
Negative. Positive or negative in the denominators first? Negative and
Positive.
positive. So then we know where that graph exists now. That has got to be above the x-axis, and then the final graph must do this. Okay, and technically I would need to get rid of these little red dots here. So let me try to clean that up just a little bit. Finish. So get that asymptote back, get the intercepts back, and now just draw the rest of the graph in. So this is what the graph should look like. Has some sort of cubic looking thing in the middle, and it's got the rationals on the outside. It's still paused. Okay, for the next graph, I'm going to go a little bit faster. Unfortunately, it requires long division because of the degree on top and the degree on bottom. So actually, I'm going to kind of cheat it. I'm going to do synthetic division, kind of bypass the long division moment. So I'm going to quickly do synthetic division by bringing down the 1 first to start, multiply, add, multiply, okay, and this is our remainder, add. So this can be rewritten as x, okay, plus 2 with the remainder plus 4 over x minus 3. So the first thing I want to do is rewrite it like it wants to be. Just so you know, the earlier problems that you had in the homework, that's exactly what you were doing. You were doing division to see what it was trying to be, and I'll hit those questions here in a second. Okay, so let's just finish off as much of this graph as we know. First of all, there's an asymptote at x plus 2, crosses right there at 2, slope of 1, x plus 2. So we have a slant asymptote. Okay, what makes 0 on the bottom, either with your original answer or your original question? What makes 0 on the bottom? 3. So this wants to have a 3, x equal 3. Any intercepts out there?
Yeah. 2 and 1.
2 and -1, is that from the binomial breakdown that I'm not seeing there?
Yeah.
Okay, so what is that breakdown? X, 2 and 1, -2 plus 1, so we do have intercepts at 2 and -1, and the y-intercept's at positive 2/3. Notice, though, we have 2 asymptotes, and so we've broken up the universe, the xy universe here, into 4 quadrants. Can the graph exist above the x plus 2 line and below the x plus 2 line left of 3?
No.
And it can't do the same right of 3. It has to either be above or below. So I'm looking basically for 2 parts of this graph. That's it. 2 parts of this graph. The graph must exist either up here or down here, or either way up here or down here. So let me show you how I can get the answer to the far right side. This says that the remainder, that the graph wants to be x plus 2. It wants to be x plus 2. That's the end behavior of it. It wants to be x plus 2. Plus, if x is positive, a little more. Does everybody see? Plus, if x is positive, this is going to be a positive fraction. Just plug and chug a 10. If x is 10, it wants to be x plus 2, 12, plus 4 over 7, so a little more. So I can plug and chug a point real quick to feel, or just read the way the remainder is. What about if x right here, if this x in the remainder, in the denominator of that remainder fraction, what if x is negative? Wouldn't that be subtracting a little, right? If x is negative 100, let's go in behavior, big numbers. X is negative 100, would this remainder be minus? So then down over here in this line, below this asymptote over here on the far left, I now know the graph has got to be slightly below that. So I've already got a feel of where this graph is. I think at this moment, you could confidently sketch in some sort of graph that uses the asymptotes up in the upper right, comes off the asymptotes, curves up on the slant asymptote. Over in the left, combined with these 3 intercepts and the fact that if x is negative, that means it's below, it's down here, then that graph must come up, hit a couple of these points, and then use the asymptote and head down. Again, the limit as we go into 3. Coming from the left, it's got to be negative infinity. Okay, and I could probably do some sign checking, some plugging and checking, but I think I have enough dots and enough knowledge using just the long division remainder. Using this remainder really helps you analyze if I'm above or below.